Hello, my dear children. Welcome to my channel, Sudhir Sir Chemistry. But in atomic structure, now this is the second part, that is a fundamental particle. In our previous video, what we learned that is a limitation of Dalton's atomic theory, that he is unable to explain the internal structure of the atom. Now we'll see beta what is the internal structure of the atoms and all. You know the structure of atom, how it will be. It is a spherical and having a positively charged nucleus at the center and negatively charged electron lie outside the nucleus. So this is a negatively charged particle called as a electron, and this is a positively charged particle which is at the center of this circle, and that will be called as a what? Nucleus. That will be called as a nucleus. So negatively charged electron lie outside the nucleus. Now we'll understand this one clearly, beta. This positively charged particle, which one we are calling, it is having a positively charged proton and neutral charge neutron. So this is nothing but a nucleus only, beta. This is a nucleus. So this nucleus is containing what? Positively charged proton and neutral charge neutron. And one more, this negatively charged electron will always be lie outside the nucleus. Do you know whether this positively charged proton and neutral charge neutron together they are called as a what? Togetherly they are called here as a nucleons. So what is a nucleons? That is a proton and neutron together called as a nucleons. And why this nucleus is getting the positive charge, or how this nucleus is getting the positive charge? But the nucleus is getting the positive charge due to the positively charged proton present on it. So indirectly what we saw beta, ki now atom is there, that atoms can further be divided. But when these atoms can further be divided, what are the particles we are getting? A negatively charged electron, right? But I'll write complete word. Further be divided, and it gives negatively charged electron, positively charged proton, but a neutral, that is a neutron. Even it gives rise to positron. It gives rise to beta antiproton. It gives rise to meson. Are you getting me? Means when the atoms is going to divide, what are the particles will come from here? Electron, proton, neutron, that is a common everywhere. Even it gives beta positron, it gives antiproton, it gives meson, right? It gives neutrino, it gives neutrino, right? So these are the pions. One more is there, I remember. Pions. But these are the particles are coming from the atom. But among all these particles, only these three particles are the stable particles. Are the stable particles. That means they can exist. But the other particles like a positron, antiproton, meson, neutrino, pions, they will come from the atom, and within a fraction of a second it will disappear. Why? The remaining all are the unstable. Because of that, these three particles, which beta electron, proton, and neutron, are called as a fundamental particles. So what is the fundamental particle of the atom beta? These electrons, that is a negatively charged, proton, that one is positively charged P plus, and neutral charge, that is a neutron, that is N, are considered as the fundamental particle of the atom, because these are the particle exist from the atom and they are the stable particle. So if anybody will ask you what question for what is the fundamental particle, what you have to answer beta? Electron, proton, neutron are the fundamental particle, but remaining particles are the unstable particle that will exist from the atom, but within a fraction of second it will disappear. Right? Now we are going to learn here, these electron were discovered by whom, proton were discovered by whom, neutron were discovered by whom. That part we are going to see. Right? Take a screenshot of this one. So beta, now we understood what are the subatomic particles are there, electron, proton and neutron. But I am going to draw one of the chart for this one. Just try to understand. First I will write here as a subatomic particles. Can you tell me beta what are the subatomic particles we learned till now? One will be the first one is the electron, that is a subatomic particle. Second one is what? Proton. and third one is what? Neutron. I'll write on this side. One is electron, second one is a proton, and third one is a neutron. See beta, this is a subatomic particles that we learned till now. Beta, in this subatomic particle mein, first of all we'll see this electron were discovered by whom? Did you remember? Electron were discovered by J.J. Thomson. Remember this one, it is discovered by whom? J.J. Thomson. Then proton were discovered by whom? Goldstein. Proton were discovered by whom? Goldstein. And neutron were discovered by Chadwick. These are the name of the person, those who discovered these fundamental particles. So electron were discovered by whom? J.J. Thomson. Proton were discovered by whom? That is Goldstein. And neutron were discovered by whom? Chadwick. Right? Now we'll see with a mass. So two are there. One will be called as a mass and another one will be called as a relative mass. But a relative mass. So what is the mass and what is the difference between the mass and the relative mass? But a relative means we are considering proton as a one particle with compared to proton, what is the mass of the electron? For example, the relative mass of this electron is 1 by 1837 times. So proton will be considered as a what? Beta 1. If you consider the mass of a proton is a 1 and compare the mass of the proton with the mass of the electron, but electron mass is 1 by 1837 times the mass of the, means if you compare the mass of electron with the mass of proton, so mass of electron is 1 by 1837 times the mass of the proton, and mass of neutron also we are considering here as a 1 because it is a relative mass beta. This is the relative mass. Okay. Now what is the actual mass of these electron, proton and neutron? But if you want to see the actual mass in the kg and all, I will say mass of these electron is 9.18 into 10 to the power of minus 31 kg. And if you compare the mass of the proton and neutron, approximately same value will be there. One is having 1.673. 1.673 into 10 to the power of minus, actually it is in kg beta, 10 to the power of minus 31 kg, but here if you count it is a minus 27 kg. And if you see the mass of the neutron also same, 1.673 into 10 to the power of minus 27 kg. Now we are getting the doubt, sir, what is the difference between these and these, right beta? 1.673, 1.673, both are having the same, but what I will do, small differences I will show you. 673 beta, 675, it's a better way to remember. 1.673 is a mass of the proton and 1.675 is a mass of the neutron. So right, please take a screenshot of these values. Now, but here whatever the mass we wrote, like a 9.18 into 10 power of minus 31 kg and all, if you see the mass is in AMU, atomic mass unit. So for this electron, 0.123, see beta, 0.000546 AMU, atomic mass unit. Please remember this value beta. Definitely this value will help us to solve some kind of numericals they will ask in IIT JEE as well as in the NEET also they are asking beta this kind of the questions. I'll tell you what kind of the question they will ask and how this value will help for us to solve that kind of question, right? 0.000546 AMU. Come for the proton beta now. If you see the mass of the proton in AMU, it become 1.00728 AMU, atomic mass unit. Right beta? 1.00728 AMU. Come for the neutron, it become a 1.0086. But in some other, instead of writing 0086, we can write 008665 AMU. So but these are the three values you have to by heart, that values of the electron, proton, neutron given in what? AMU. Relative mass over and actual mass also over. Come for the charges beta now. What is the charge over the electron and what is the relative charge of this one? So charge of the electron, if you'll see, charge of electron we are able to find out only in the coulomb, and that is electron is a negatively charged. So minus 1.6022 into 10 to the power of minus 19 coulomb. C is what beta? It's a unit that is given in the coulomb. And if you write this charge of the electron in ESU, we can write as a minus 4.8 into 10 to the power of minus 10 ESU. What is the ESU? Electrostatic unit, right? Come for the charge of the proton beta. Proton is positively charged, so plus same value 1.6022 into 10 to the power of minus 19 coulomb, or plus 4.8 into 10 to the power of minus 10 electrostatic unit, that is ESU. And as we know, a neutron does not have any charge, it is a neutral, so charge of this neutron will be taken as a what? Zero. Is it clear? These are the electron, these are the proton, and this one is a neutron, that is a charge of this particle. Take a screenshot of. Now we'll see beta what is the relative charge. It's a very simple. If we'll take here the relative charge of electron, proton and neutron, see how simple it is. We know electron is a negatively charged, so minus 1, proton positively charged, plus 1, neutron does not bear any charge, so it become a what? 0. But one more table is there, and that is called as a specific charge. I will tell you, please listen very carefully. Specific charge is nothing but it is a ratio of E by M. What is a E beta? Charge. What is a M? Mass. So I should write beta specific charge means it is a ratio of charge of the particle by mass of the particle. We can write beta it is a E by M ratio. That E by M ratio called as a specific charge. Now charge of the electron and mass of the electron, if you do this E by M value for electron, the value we are getting here as a 1.76, that I remembered, 1.76 into 10 to the power of, I think a minus 19 beta, minus 31, it goes to plus 31. 31 minus 19 you do here, 31 and 19, so 20, it become 10, 11 and 12, 0.176 into 10 to the power of means 1.76 into 10 to the power of 11 coulomb per kg. We can solve it better, but better way to remember 1.76 into 10 to the power of 11 coulomb per kg. Another one, specific charge of the proton, that is a E by M. E charge, M is a mass. That value if you solve, I am getting some 9.58 into 10 to the power of 7. 9.58 into 10 to the power of 7 coulomb per kg. But I'll tell you, by heart these values, definitely it will help you to solve numericals based on that one. And obviously beta, neutron does not bear any charge, so specific charge of neutron will be taken or considered as a what? 0. So this is a, we have done a complete table of the fundamental particle. Is it clear beta? Are you able to see clearly? Right, very good. Take a screenshot. So beta, these are the fundamental particles we have seen. Now in our next video, I am going to discuss with you discoveries of each particle, discoveries of electron, discovery of proton, and discovery of neutron. Electron discovery, how the discovery of electron was there, what it will be called, obviously called as a cathode rays. That means what is the properties of the cathode rays, then discovery of the proton called as a anode rays, and then discovery of neutron. That part we are going to discuss in our next video, right? Thank you beta, thank you very much, have a great day, take care, bye.